Hello, today I will explain and summarize the paper which have a title A Classification Framework for Software Components Model. In the beginning, component-based software engineering is an established area for software engineering. So, it is the area for software engineering in basic. Building systems from components comes from civil or electrical engineering, not software engineering. Because of the software engineering components, it's differ from civil or electrical engineering component. So the software engineering components, it is differ from a civil or electrical engineering component. So what is a software component? A definition says is a unit of composition with contractually specified interfaces and explicit context dependencies only. A software component can be deployed independently and is subject to composition by third party. So this definition, it's become for a software component, but this definition is not general. It doesn't contain all the cases of software components. So a new definition came. This definition says a software component is a software element that conforms to a component model and can be independently deployed and composed without any modification according to a composition standard. So the component model, it defines a set of standards for component implementation, naming, interoperability, customization, composition, evolution, and deployment. So we can determine these standards for any component model. We can put it on a set and say this is the set of standard for a component. The component model, it defines a set of standards for any component. So, and this is deal with one, rules for the construction of individual components and rules for the assembly of these components into a system. So this definition says, or we can say it deals with the first one. It's focused for the individual component itself. The second one is focused on the components in the system, more than one component in the system. Where we can use component models. We can use component models in two areas, embedded systems and particular business domains. Embedded systems such as automotive software, consumer electronics. In particular business domains, we can use it in finance, telecommunications, healthcare, transportation. What is the main concept of component model? The main concept of component models. The first main concept is component properties. It includes functional and extra-functional specifications of individual component. Here we focused on the individual component itself and we specify and determine its properties. Composing components, it is meant to include mechanisms for component interaction. Here we focused on more than one component and their interaction between each other or between one component and the system, the whole of the system. Component-based system identifies. The component-based system identifies three things. The first one, the components itself. The second one, the underlying platform. This is the platform where the components are interact and be on it. Binding mechanisms, this is the mechanisms that we bind two components or more with each other. So this is the whole system: component, the platform where the components are, and the mechanisms that bind each component to each other. So we say component, component, component. What is the component? The component is a software module that includes both two things. The first one is the execution code, and the second one is the machine readable metadata. It is typically including the interface signature, which explicitly describes the services that the software provides and the services that it requires from other components and its execution environment. So the component is it's include the first one is the execution code. The second one is the machine readable metadata. This machine readable metadata describes the services that the software provide for the component and the services that the component provide it from other components or from other executive environment. The classification framework. The basic characteristics and the principles of component models. What is the basic characteristics and the principles for component models? We have three characteristics. The first one is life cycle. The life cycle for the component. The life cycle dimension identifies the support provided by a component model and the component forms throughout the life cycle of the component. So here we describe the life cycle, the whole of the life cycle of the component. In this picture, we see the component life cycle. It's begin from the requirements. We collect the requirements and modeling it by specificate it, interface, models, metadata. Then this modeling, we implement it like a code, source code or executable models. Then this implementation, we collect it on a packaging, on a package. We say this stage is a packaging stage. It is like storage. We can consider it like a storage. It's contain repositories, packages, metadata, and then these packages we take it and deployment it like installed files. Then this deployment we execute it in execution stage and we got an executable code. So this is the life cycle, the whole life cycle of the component. The second classification is, the second characteristics is construction. This is mean the process or method of building. Here we describe how can we build a component. What is the process? What is the method to build a component? And it's include three things. The first one, connection points. This is the connection points that connect each component to each other. Mechanisms for establishing connections. These mechanisms, it determines for us how we can connect components in a connection point. What is the mechanism? The third one is a communication itself. This describes the communication itself that happens between two components to connect it to each other. The third one is extra functional properties. The extra functional properties dimension identifies the facilities a component model offers for the specifications, management, and composition of extra functional properties. The minimum criteria correspond to the definition of component models. This minimum criteria correspond to the definition of component models. So here we can determine by a minimum criteria that this is a component model. The first one, a component model includes a component definition. The second one, a component model provides rule for component interoperability. The third one, component functional properties are unambiguously, this is the first one, specified by a component interface. A component interface is used in the interoperability mechanisms, and the last one, a component is an executable piece of software, and the component model either directly specifies form or unambiguously relates to it via interface and interoperability specification. Component models. This is some examples of component models that we take it, that the paper talk about it in literature review field. This is some examples. I took just 6 of them. AutoSAR, Automotive Open System Architecture, BIP, Behavior Interaction Priority Model, Component Models, CCM, Corba Component Model, and Compoint-Based Design of Software Distributed Embedded System version 2, and Components, and Enterprise Java Beans. Component models and domains. We distinguish the component models as as two things. One, general purpose component models. Two, specialized component models. These two types of component models. The first one, general purpose component models. The second one, specialized component models. They are equal in use according to their dominant use. So even if they are two different types of component models, but they are equal in use according to their dominate of use. Where we use it, where is the specific field for each type of these component models, we use it equal to the other type of component models, each one on their dominate use. Two domains for component models. We have two domains for component models. The first domain, the embedded system. The second domain, the distributed information systems. Here we have that the component models in the embedded systems domain, they have some common characteristics. They share some properties, such as the first one, pipe and filter interaction styles. Every component models in the embedded system domain have this characteristic. Components are usually deployed at compilation time, resource aware, and support for the management of timing properties. Finally, in this survey, we have presented a framework for the classification and comparison of component models. We classified and compare between component models. Then there is no complete set of principles that applies to all component models. We cannot take all the component models in the world and apply the same principles on it. We cannot. There is no complete set for them. The intention of this work is to increase understanding of the component-based approach by identifying the main concerns, the common characteristics, and the differences between component models. The proposed framework does not include all the elements of all component models, since many of them have unique solutions. So not all the component models are implemented in the framework, because many of them have a unique solution. We cannot general. And the framework identifies the minimal criteria for considering a model to be a component model. So we say, what is the minimal criteria that we have to do or to put to consider this model is a component model. I finished the summarization. I wish it will like you, and thank you.